All right, welcome back. We are COMP2142. That's Game Artificial Intelligence 1 in the winter 2026 semester at Georgian, and it's week 1, part 2 of our broadcast and recording together. When we left off, we were going to talk about game AI. I'm just going to switch all the way down there, which is down here. And I want to talk about some games. The first one, which is our lovely game Pac-Man. Okay, with an ad.
Someone into your home.
How about that?
Trust is everything. And
I like that. Yes.
We earn it
Pac-Man with an ad.
With over 150,000 five-star reviews.
And of course
we treat your home like our own. Get $1,200 back on
$1,200
a featured
bucks
furnace.
back, buddy. $1,200. I know, right? I love it. Well, they got to capitalize somehow.
This is Ben.
Oh, wow. I love that one.
There's something wrong with Ben.
Could be.
It's me. Casey.
Maybe. Primate.
Domino's best deal ever.
Come
Get
on.
a hand-tossed pan, thin crust, or New York-style pizza with any toppings for only $13.99.
It's amazing. All right, finally. Finally. Okay, who's not played this game? You got to play the game. So why Pac-Man? Why am I saying this? Pac-Man was like fledgling AI. I played this game when it first came out in the arcade, way back. I know you guys, when I say arcade, some of you still have never seen an arcade machine, but yeah, it was a thing. Pong was a big thing. We talked about Pong, kind of like yesterday, right? So, because it's multiplayer. But Pac-Man is interesting because it had all these ghosts. Every ghost has a name. And the thing about it is the ghosts had basically 3 states. They used the state machine. Chasing, scattering, and frightened. Those are the 3 states that they would use. And every ghost, actually, you can look this up if you really want to reprogram Pac-Man today. You can look up each ghost has a name, and each ghost has an algorithm. And you can actually reprogram Pac-Man with the information that's online today. Okay? But this, to me, when I first saw Pac-Man, how it chased you and all this kind of stuff, I mean, it was revolutionary, right, at the time. It may not look like it today, but back then, it was huge. Okay, so this is one of the first things, using a state machine. And we're going to talk about state machines and how to put them together, this semester. Golden Axe, right? Another one that was really interesting. So we talked yesterday about another kind of game that was an RPG. This is similar to an RPG where you have a small little group of people, right? You can select the player, and when you play against the AI, the enemy characters, what they would do is they would be a little bit more intelligent in terms of how it would come at you. So they kind of homed in on the player and came at you. Very, very simple algorithms that were used back then, but that definitely Golden Axe was a revolution. GoldenEye 007. It used more like crowd AI, and the way it would do it is, for the first time, because GoldenEye 007 was a stealth game back in the day, and if you've ever played a stealth game where you're in the light or in the shadow, that's where this thing came from. It came from these guys, right, when they made it. And what it would do is, if you were alerted, if they were alerted to you, they would alert all the other AI in the area, and they would come at you, right? So it was a whole new thing. It had never been done before, and it's something that was really, really cool at the time. So again, so the idea of sensing you. So one thing that we're going to be talking about this semester is the 2 senses that we use a lot when it comes to programming AI from scratch, which is line of sight. Hey, I can see you, right? If I can see you, I can shoot at you, right? Or if I see you, then I can detect you. And what do I mean by seeing? Like, I'm going to basically intersect a line, a ray, that I'm going to cast, or some kind of cone or whatever, from me to you. And we've seen that example when we made our sensing, component in Unreal Engine. We've done that. Sensing is a big thing. The other one is some kind of sensing radius. And we've done those things as well, where the sensing radius detects the player. The player's around. We can't see the player. I may not have them in my line of sight, but if I can sense the player, that means I can look for the player. So I've heard him somehow. He's done that stuff. And we're going to talk about that today in Unreal Engine a little bit. So that's GoldenEye 007. when we talk about AI, I want to develop this idea of a model with you, okay? The AI model. And the AI model that we're going to be talking about is this. It kind of has this idea of the AI gets information from the world, and from the world, it makes some decisions, right? In this course, we're not going to be talking about decision making. We're going to be talking about decision making in the next course. We're going to be talking about movement more than anything else, okay? So this little part of the AI model right in here, okay? But we are getting kind of input from the world itself. So really, what it says here is not all game applications require all 3 levels of AI, and that's true because some games don't really have enemy characters. The enemy is the game. For example, a puzzle game of some kind, right? So, the 3 things that we learn about in design are maybe the 3 C's are camera, controls, and character. Maybe the character being not just you, but the enemy characters as well, right? So movement is what we want to talk about in this course, and sometimes we have these complex movement algorithms, things to avoid obstacles and that kind of stuff, and that's really the topic of this course. I also want to talk about this idea of AI agents. So whenever we think about an AI, we're not talking about just the enemy itself, but the brain of the AI itself, right? So here is an example of this AI agent where we have the environment. We might have something called a perceptron or some kind of perception system that gets input from the environment. And then from that input, using its sensors, we have our actuators. And those actuators allow the AI to propagate or use locomotion and animation around the world, right, in order for it to affect the environment through its actions. And after it affects the environment, it's going to get, since the environment's been changed, the perception is going to change about the AI, and it's going to actually go through that whole loop again. All right, so that's what the AI agent's all about. AI agents are also something that they talk about today in terms of, I don't know if you guys have heard this term, agentic AI. You heard about that one? So what is agentic AI? Well, think about an agent like an LLM, a large language model like ChatGPT, that can shop for you. You've given it your credit card, right? Oh yeah. And it'll do all kinds of stuff for you. It'll just say, okay, go do this task. And if it has to buy something or if it has to do something, it'll go do that task and come back. And without your intervention at all. It'll give you you'll give it some requirements, and it'll go do something and come back. Right? Agentic AI. And it's becoming more and more something that we're going to see, especially in 2026. Right? I think probably 2026 is probably going to be the year of agentic AI. We're going to see that more than anything else. But think about these AI agents that are able to perceive the environment, perceive the universe, in some way or another. The universe we're talking about is your universe, the universe you create in your game world, right? And imagine if they can wander around and explore the game world on their own without you having to program them. That is the topic of reinforcement learning, which is something we're going to cover in AI 3, all right? Which is next year again. Let's continue. So, what the heck is good AI, right? And I think the main thing is that bigger is not always better, okay? Just because the AI is, holy crap, really complex. I'm definitely an old guy. I can't ever eat that stuff, all right? Just because an AI, sorry, he just has this massive like donut, right? Sorry. He threw me off now. See what's happened, right? The idea here is AI can be very, very complex, right? But what we want is that good AI must work with the player, not the coder. Just because we think the AI is really cool doesn't mean it's right. It's really what is good enough for the player. What kind of challenge do you want to produce for the player themselves, right? So before we do that, let's talk about this in a second. And I want to talk about this really quickly because of this idea of what is good enough, right? So levels of challenge. Who loves challenge? You love challenging games. Love challenge though. I mean, you like playing. So Jackson, are you like the Dark Souls master?
Well, I haven't played like Dark Souls.
Oh.
Well, I probably should. I probably would enjoy it, to be honest with you. I just haven't got around to it yet.
People love it. People love Dark Souls. You love the Dark Souls stuff. And the reason why I'm bringing Dark Souls up again because Dark Souls is like the hardest game you can goddamn play. Dark Souls 3, for example. When you first learn it, and forget Elden Ring, I'm talking Dark Souls, right? I feel, and so even Demon Souls, the first one is quite difficult. The reason why is because people quit. It's too hard for people, right? They're like, holy crap, I can't get by this level, or even Bloodborne. There's another one, Souls-like, and I think Bloodborne is probably the best of them. Honestly, I love Bloodborne the most, right? But think about those kind of games. Those Dark Souls or Souls-like games. They're adaptive. They use some kind of perception system to detect where you are. They adjust the bosses against you. They will, right, if you're close in. They do have a pattern, though, and you can defeat them. Every one of those creatures that you find, or those monsters or encounters, non-playing characters, they have a way of you can defeat them all. But you need to do it, and you're probably going to die, I don't know, for me, hundreds of times, right, before I actually get through the whole thing, right? That's not for everybody. Not everyone likes those kind of things. It's not like you can look at them and go like, wow, I really love that level of challenge. Some people like a fairly moderate level of challenge, like, I don't know, the challenge you might get from Fallout 3, as an example. That might be good enough, and I'm saying Fallout 3, not Fallout 4, because I think still Fallout 3 is better. I know Fallout 3 is they're thinking the remasters are imminent, by the way, for those people who care, right? So I'm going to definitely download that. Even Oblivion, I think, in many ways, I like better than Skyrim for some reason. I don't know why. I think that whole era of games, I know. You're thinking I'm like, I'm speaking like in tongues. But what I'm talking about here is,
You play New Vegas?
Yes. I like New Vegas as well, right? Totally different kind of game, and I really do like it. It's definitely one of my favorites. I still think I like. My son kills me when I say this, but I'm like, I like Fallout 3 more. He's like, no, Dad, New Vegas is the best one, and I'm like, I know you're right.
I like the cities and
It's really cool, but I don't like the courier too much. I'm more like I like the person from the vault, right? So that's what I like more. I think it's the story that does it for me, right? Although the new Fallout season, they say like it's the worst version of the ending from New Vegas is what I'm not sure. I'm not sure if you guys have watched Fallout. But it's pretty good. Second season, so why am I saying this stuff? Because sometimes we make stuff that's just too hard, right? And the worst way for me is when it's too easy, right? For example, I'm firing at an AI, and every time I fire, it ducks, right? And it has a pattern of ducking. So I come out, I fire, it ducks, and I fire, it ducks, and so I come up, I don't fire, it ducks, comes back up, and I shoot it. Predictable AI is the worst kind of AI. I don't want my AI to be too predictable. I mean, if it's predictable like Dark Souls has a pattern and it's quick. There's certain things that are going to stop you from even defeating it. Even if you see the pattern, you're like, I know what to do, but I just can't get my reflexes good enough to do it. That's a whole other thing, right? Or my guy doesn't just do enough damage every time he hits because I got to increase my strength, or something like that. That's a different thing than actually seeing a predictable AI that you can shoot or evade. And a good example of that is like, I go back to Oblivion or Skyrim where the characters say something like this. Hey, I heard something. Did you hear something? You come out and then you literally hit them with something. Oh, whatever. Then you run away and they lose interest. That makes no sense. Listen, if you hit a guy on the head with an arrow, and he's got like literally an arrow sticking out of him in the game, he shouldn't run away. He shouldn't sit there and go like, they're gone. I guess they left then. I guess they left. It's not like that. That doesn't make any sense. That's really bad AI, right? And I've seen that kind of AI in a bunch of different places, all over the place, where I don't know why programmers do this, but they program the AI once you've hit them so that they lose interest after a while. Listen, man, if you come into my house and you beat me, I'm not going to lose interest. I'm going to try and kill you, right? So that's how the AI should be, in my opinion. So I think it's just a matter of how you program it. Now, sometimes it can be fun. You go in there and you hide and you shoot a guy and you go back into hiding. I guess they left then, and you come back out and you kill a guy. I mean, if that's the kind of game you like. The other thing that about games, this idea of like, scum saving and stuff like that. Save scum. I'm not into that, right? I mean, I like to play the hardest level I can nowadays because, guys, let's face it, we've all played these games a lot of times. Play the hardest level, guys. Really, do it. Right? And this way, it'll actually be a lot more challenging for you. You might enjoy the game more at the hardest level that it possibly offers. Now, sometimes it's insane. Like Doom, I don't know. That hard level is insane. Like, there's insane levels of Doom that are just, like, unfair, right? Yeah.
Yeah, I find my favorite kind of hardest difficulty is when it tweaks the mechanics to be more difficult than
Yeah.
the values. Like, I hate Skyrim high difficulty because
Yeah.
it makes everything at 4 times health and you do 0.25 times damage.
It-
It's just,
I don't like that either. And the other thing I don't like, increased health and lower damage is not really the way. I think more intelligent AI is better, right? And I also don't like it when the game gets faster. If a game gets faster and faster to make it more difficult for you, it's also poor. Okay, that's not a great solution. Oh, it's just faster. The AIs are really, really fast, right? That's not the answer. The AI should be smart. And
Playing like hardcore, I find it like makes me like go slower and like make sure I want to stay alive. Even if I die and I have to restart like a whole 30-hour campaign.
100%.
redo it,
100%. And you know what I like
I
about
didn't think I
hardcore?
wouldn't like it, but I do like it.
The thing I like about hardcore is I tend to do more side quests because I'm going slower, right? Whereas when I'm doing things on, you know, like the medium mode or whatever, the regular, right? I don't do the side quests. I go through the story a lot quicker, right? It really depends on the kind of player you are. Are you a casual gamer who just likes to play the story, or are you a person who really wants to, you know, the challenge? So I think that kind of answers the question, when is it good enough? So I want to do, from there, I want to do this. I want to do some custom collisions. And this is the part where we do some stuff in Unreal Engine. So let's pull up our Unreal Engine project and do a little bit of some stuff today before we go. Okay? So for this, I don't need a special project. I'm just going to pull up Unreal Engine 5.5.4. And I want to talk about the challenge that we have with casting. So we talked about this earlier, which is casting is computationally expensive, right? Think about what you're doing with casting, right? We always cast. I want to cast to this, cast to that. Guys, you want to avoid casting as much as possible. It's terrible, especially if you cast every frame. That's the worst type, right? So if you're doing that in your game right now for Level Up and for Rise, take a look at the areas that you're casting, and you got to think about other areas where you only do it once. Try and cast one time and save the variable as much as you can. But one thing that we want to try and avoid, and I'm just going to go into our third-person perspective project. I'm not going to have a starter content here, and I'm just going to call this, for our purposes, I'm going to save this thing up online. It's going to be COMP2142, and it's going to be winter 2026. And we're going to call this, I can't make too many big names here, but we're going to call this, I don't know if this is too long. Custom, yeah. Custom collisions. How about that? And I want to click create. So I want to talk about this because in collision detection, we do a lot of casting. Here's an example. I have an overlap, some kind of overlap sphere or overlap box. And then what are you going to do? Other cast to BP underscore player. You're going to do that a lot, right? Imagine every single time you do that, it takes up frames. And if it's not just you, there's hundreds of different interactions you're doing all the time. You don't want to be able to do that, or you shouldn't want to do that all the time. So here's something that I want to show you, and this is something that I want to start off with. So first, I want you guys to, let's go to edit, and let's just edit preferences just so we can go into our main window, just to start off. And I also want to go into our project settings here. Let's go to project settings. On the left, there is a collision area here. Go to the collision part with me on the left inside of project settings. You can see here we have a couple of things here: object channels, trace channels, and presets. Here are all the presets, my friends, okay? So I want to make let's make one new object channel. So let's click on new object channel. And I want to call this object channel player, okay? And you can give the default response for players. For default, let's just say players always block, okay? And click accept. So that's the first thing you do. You make your own object. By the way, you can do this with enemies, doors, whatever. It doesn't matter. Anything that you want to identify way over like the stuff that you're using more often. For example, if it's just a simple pawn, that's one thing. But if you want to be really specific with players and enemies, this is a great way to do this. Next, once we have the channel player, now we need two parts. I want to make a new preset. Let's make a new preset. Okay? The new preset will be the name player again. Okay? And for the collision enabled channel, let's use collision enabled, query and physics. This is the default. So object type could be world dynamic because guess what? Players or pawns are world dynamic. Take a look at the examples that we have here. Pawn, right? And then collision enabled, the object type is a pawn, right? So that is the object type. But we can choose player because we just made that player, right? Player. That's the object type, right? Before we were choosing one of these, world static or world dynamic or pawn or something else. Now we can choose player. And let's put a little description to it. Something like, player object can be used for capsules. Okay? For the player, we want to block everything except for the visibility channel. We don't want to block the visibility channel, which is very similar to what we've done with the pawn, as you'll see later on. Okay? But once you have this, then click accept, please. So that is our custom preset for players. Okay? Next, what we need is a way of overlapping with players. Let's make one more preset, okay, my friends? A new preset. And we'll call this something like overlap player only, okay? So overlap player only, okay? For the collision enabled type, we want to use a query only, no physics. That's what we want to use, okay? And I want to ignore everything except for the player. I want to overlap with the player. The object type could be world static, and you could give it a, some kind of description like only overlaps with player objects, okay, which is what it does. And then click accept. So now I have two new presets, and I have a new player object. Are you with me? Okay, so why this? Remember the challenges we have with Unreal Engine, my friends. We have to use their defaults, and we never understand how collisions occur. We're like, God damn it, why isn't this working? It's just not colliding because you're not looking at the right things. Here's how we can partition this and learn. Now, what I want to do is this. I want to make a brand new, inside my third person, right? We have blueprints. Let's make a new blueprint that we can use in here, just so we know where it is. And we're going to make it of type actor. Okay, an actor blueprint. And let's call this the, player trigger. BP underscore player trigger. So imagine using a trigger collider in Unity. That's what we would do there, right? That's what we're kind of creating. Except this would be a specialized trigger collider. Inside here, I want to double click. So I want to bring up the player trigger, BP underscore player trigger. And on the left, what I want to do is I want to add in a box collision. Let's just use box. So there's my box, okay? And for the box, let's make this the root. So I'm going to drag it to the root. So it's going to be the root component, okay? And just so we can make it visible so we can see it, let's make it the line thickness of something like 2, okay? And let's use a color that we can see, something like magenta, all right, like really ugly, all right? It's an ugly color and whatever, and we're also gonna make it so that if I look for hidden, I wanna make it so that it's not hidden in game, so we can see it for now. That's the first part, compile and save. So all we've done is we've added a box collision on top of our player trigger actor. That's what it is, a type of actor class is what we have. Now, what I want to do is in the event graph, let's get rid of begin play. We don't need that, and we don't need the tick event. But we are going to use this event actor begin overlap. The event actor begin overlap, okay? Why? Because the box is our default component. We can use this. And what I want to do is instead of casting other actor, I don't want to do this at all, right? I want to click on the box. Let's do that. Let's go to the box. And I want to scroll down to the collision defaults right here. And notice by default, the box is overlap all dynamic. Let's change this to overlap only player, right? That's what we want to find, this one. Overlap player only, this one. That's what we called it. Notice that it does the exact same thing. It says, I ignore everything except I'm overlapping with the player object. Cool, that's what this box does. Yay. So what we can say is, when it overlaps with the player, no casting, I want to print something like, let's just do this, and we'll say something like player entered. Okay, player entered. Yay. And we can also do, on the box, we can do an event actor end overlap. Let's do that. So actor end overlap. There we go. And I'll use another print statement here like this, just to prove my point. So I'm not casting from other actor. All I care about is one thing. And instead of player entered, player left. Player left. There we go. So now we have all we need for the trigger collider. All right? Compile and save this. And what we're going to do is we're going to drag the trigger collider into the game world. Let's drag it in. And I want to put it just before this ramp over here as an example. So we're going to move it over, and we can use the R key to change the size, right? And I want to make it something that looks like maybe this. The W key can be moved up. You can move it up, so almost like a little portal that we're making. Maybe make it a little bit less big, like something like this. We would pass over. And so when somebody goes kind of towards this ramp and passes through this ramp this way, I want, this thing to trigger. Make sense? You can put this at a doorway. Now, it's not going to work with the player yet. You know why? We haven't changed the player object yet. We need to change that next. So compile and save, or just save. Go back to the player now. Here's the player. And let's go back to its capsule component. So the capsule component, if I scroll down, right, you can see that the preset is pawn. Let's change that to player. Look what happens when we do that. The player preset is collision enabled query only, just like we had for the other capsule, except the object type is now player. Now if I play like this, and if I press play, and if I pass through this area, we should get player entered, player left, player entered, player left. And it's a beautiful thing, my friends. No casting. Why am I showing you this? You're going to need it for your game, for Rise and Level Up. 100%. Some kind of trigger that you're going to use for players or enemies or whatever, and you don't have to cast. And it's super easy to use, and you can just put any kind of function on it right away. Okay? Custom collision objects, my friends, which is what I want to show you. Why am I showing you this in AI? Because just like you, I'm going to be using this for our own custom things that we have in place. Where this is really good is if I want to activate an AI, right? And later on, not this year, but next year, when we talk about behavior, imagine if, we have a nav mesh and we have some kind of nav mesh agent, an AI agent. We don't want necessarily for them to be active in the entire open world. I have a massive open world. Do I really want my AI agents to be active all over the world? Or should we activate them when we pass through some kind of trigger? Think about the performance game we're going to get. They're completely standing still until we've come into their town, right? As soon as we come into their town, there's activity. How does that happen? We activate them. And when we leave a town, we deactivate them, right? So that we don't have to have bad performance. All right, this idea of good performance and bad performance is an optimization that I'm sharing with you so that you can implement it today. Don't wait to do this for Rise, all right? Do it now, okay? Because it's a big problem. Questions around custom collisions. By the way, I highly recommend you also do this for your enemies. So example, I'm firing a bullet. My bullet only hits enemies. Doesn't hit ground or whatever, and it can do different things, right? You can program different parts of the world like that. I'm walking on a certain surface, I want to make a certain sound. How do I know that? Because the surface has its own custom collision object, right? Okay, disadvantages. I got to put my hand up for this. C++. Custom collision object with C++, right? You need to do the same things we normally do. Remember that there's two parts of the Unreal Engine that we're using, right? The C++ side, and then there's the, blueprint side. On the blueprint side, it's super easy. By the way, let me prove to you that nothing else is colliding, because I didn't do that. So one way to prove that is to push a block. Let's try this out, right? So if I push a block like this, hello, right? And normally what would happen is, if anything, because I didn't say what type of actor is colliding, and if I push this block in here, right, then that should collide right there. Look at that, right? So it should, react to that overlap, but it doesn't. Only this one does, right? Notice how he entered and left, right? And that's what we're trying to do here. You can make these custom collision areas that are really, really powerful. So questions around this. This is what I want to share with you today. It's a little tidbit. I'm going to be doing that at least once a day with you guys when we see each other, because I want you guys to be successful with level up and rise, right? I don't want you guys to be stuck. Oh my God, Tom, I don't know why, but it's not colliding. Let's put something even smarter together before we go. Let's add in a nav mesh, all right? And put together that nav mesh agent that we normally do. Okay, let's do this together, all right? So,
Another blueprint?
no. Yes, but not right away. I'm going to go here and I'm going to go to, volumes. And under volumes, I'm going to put a nav mesh bounds volume. Remember how we did this? We put the nav mesh bounds volume in the 000 position, right, of the game world. And then what we want to do is we want to expand this, the extents, right? And we want to kind of say, like, we want to kind of span this out, if you will, so that it incorporates the entire level, right? So what we can do is, first of all, we can press the P key to see what it sees. Right now, the nav mesh is only in this little block. That's where it is, right? But we want it to encompass the whole level, so we can increase the scale, this way. And we can increase the scale that way until it kind of covers most of our level, right? So nav mesh agent is something we're going to put in now, all right? Here's something else. I didn't make it so that it can go up on certain ramps. Notice that this ramp over here, these ramps right here, it doesn't go very high. So you can make your nav mesh also bigger that way as well. And the higher you make it, the more of these ramps it will cover. So notice now it covers all these areas. Okay? So nav mesh is important because it gives you the ability for you to, for the AI to track you. Okay? So now I want an AI, all right? And we're not going to create an entire AI. That just takes too long. But let's suppose I want to use a character, a mannequin, as an example. So let's look at mannequins. And it'll be a scary mannequin. It'll be Quinn or Manny, right? But they're going to just follow you around like this with their arms like this. Oh God. They're coming at you. They're really scary. Okay, I find them scary. All right, and that's what I want to use. I want to make a brand new blueprint. So we'll go to blueprints and we'll make an enemy blueprint. So blueprint class. Again, you could use a pawn for this one, or you could use a character. Either one is fine. Character just is loaded more with stuff. So BP _ enemy. Right, pretty straightforward stuff. And for the enemy mesh, the skeletal mesh, we can pull in kind of something that makes sense. So I'm just going to use Manny for the mesh when they feel like skinning. There he is. And let's pull him down somewhere like that. And let's also rotate him because he's got to be rotated some degrees, because right now, notice the arrow's over here. So he's got to be rotated around that way. So I'm just going to rotate him like so. Right? There we go. And now he's looking in the right direction. Yay! There's Manny. That's my scary enemy. So one thing about this is if I look at the AI, if I type in AI controller, right, or if I just type in AI at all, let's go back up to the enemy itself. So if I go AI controller, notice that the controller class uses the AI controller that's built in. you can override this. You can make your own AI controller, and we will be doing that at some point in the semester. But here you can see that that is something we can do. Remember how we do the AI stuff, right? In the event graph, right? What we want to do is we want to use some kind of move to. So let's get rid of these for now, all right? And I want to create some kind of move to. So if I just go from the event begin play and I go AI move to, notice that we have this little clock. It looks like a clock on the right side of the node. One thing to note, my friends, you cannot use these nodes inside of a function. If they have the little clock around them, that's this one, the delay nodes, you cannot make those into a function, okay? They have to stay here in the event graph at this level, okay? So that's FYI. So we have the pawn that we want to move. That would be self, right? And then the destination is where we want them to move to, or we can kind of use the target actor here, the target actor. So we could get a reference to the target actor, right? So we could say something like, let's make a new variable here, and we'll say target actor. Okay, and the target actor could be of type, something. Let's say, for example, we want to make it of var specific type, BP underscore third person character object. So that's what we're doing there. And then we can take this target actor, we can expose it, as an example, and we can drag and drop that in here. So that's the target actor. And we have an acceptance radius. That's when, if you remember, that's when they stop coming towards us, right? As an example, that's when it stops happening. And the acceptance radius, you can move it maybe to 25, right? And you can also check this stop on overlap if you want as well. All right, so this is what this AI move to tool does. It allows you to, use the nav mesh to move across. One thing also is if I type in possess, type in the right thing here. Here we go. So notice if you go to possess or pos, I just typed in pos, there's two options here. Auto possess player, disabled, right? And then auto possess AI, placed in world. Okay, one thing to notice is there's a few options here. One of them is placed in world or spawned, right? One of the two, or placed in world or spawned. So if we want to spawn a enemy agent, as an example, right? Then we can just use spawn. Or if they could be placed in the world and some of them could be spawned, let's say we had a spawner after you killed them, then you use this option, okay? For now, we're just gonna place everything in the world, so we're just gonna use the first option. The other one is auto possess player. And notice it says there's different players that can auto possess. We're not gonna use that one, okay? That's for other multiplayer reasons. All right, so would this be enough? Is this all we need? What do you think?
Probably not.
Am I missing something? Yeah.
You need to find target actors.
Okay, so I could, or what about if I put this guy in the field? Let's get our enemy, put him in there. He's now in level. And then if I go to, let me just make sure I make it easy for us to find. So target actor is right now, if I click on target actor, that is part of the default category. Let's add that into AI. Let's add into the AI category, right? So all I've done is change the target actor variable, which is exposed to the instance editable. I'll compile and save. And if I go back out here, and if I search for AI, then I have access to the target actor, and I can use the eyedropper tool eventually to pick me. All right, that's possible that I can use. Now I'm not spawned in the world, right? So that's a problem. So I could select the actor this way if I was going to have a target. Let's make another target. Instead of like me being the actor, it could be any actor. But look what it says. There's only one actor that's possible, right? Because we are specifically looking, target actor is of type BP underscore third person character. Okay, so what's another way to do it, to go after the actor? To have some kind of sensing radius. So I can add a sensing radius on top of the character, right? And if that sensing radius looks for only players, overlap only player, then I know where the actor is, right? Except we don't have to chase them automatically. So let's add that in. So back to the enemy for a second. back to the enemy. Let's add in some kind of sensing radius. So I'm going to go here. I'm going to add a thing here, and let's add in a sphere. So here's a sphere collision. And if I go to the viewport, we're going to call this sensing radius. There we go. Sensing radius. Go to the viewport. And let's look at the sensing radius themselves. There it is. And I'm just going to go to this. Sensing radius is quite small. Let's make it much bigger. Let's make it something like, I don't know, 10,000. Right? It's really huge. Okay, and let's make it so we can see the sensing radius. Why not? Hidden. We'll make it not hidden in game. And we'll give it a color for the sensing radius. So let's say we'll make it thick like 2, like before. And we'll give it another color like, I don't know, red's okay. That's fine. So if I compile and save, just doing that, you can see that for the sensing radius, let's click on to our little enemy here. Here we go. Here's our enemy. Where's the sensing radius? It's way over here, guys. That's how big it is. It's way out here, right? So he's already in sensing radius. Tell us. Let's say if he can hear this much. This is a quick and dirty way of doing it, right? So if I go back to the enemy, so what do I want to do with the sensing radius? If I go back to the event graph, then I can say sensing radius. If I go begin overlap, event begin. So I want to do, and the easier way even to do it without even thinking about it is this one, on component begin overlap. If I do one of these, when I overlap with the player, then I want to set my target actor to the player, right? That's what I want to do. Okay, how do I do that without doing casting? I go to my sensing radius and I go to my collision information, right? So let's do that. Let's go back up to collision. And instead of overlap all dynamic, I'm going to overlap player only, right? Oh, player only. And once I've done this, that means this only overlaps with the player. I don't care about anything else, right? And if that's true, then when I have an overlap, what do I want to do? I want to change the target actor. That's the target actor. And I want to say that the other actor, I want to set this target actor as the other actor. Now this, do I have to cast now? Let's think about this. If I just drag and drop this, set, and I want to set the target actor as the other actor, is that possible? No. So one way to do that is to change this to, instead of a third person character, we can change it to actor. So I can do actor object reference. Here it is. I don't want to cast, remember? So I don't want to cast. I change it to actor object reference. There we go. And now, can I do it? Yes, I can. So the other actor is the target actor that I overlap with. But remember, I'm not overlapping anything but the player character, which means I know where I'm going to go. Let's try this out. See if this is enough. And play. Oh man, he's not moving. Why not? Well, first of all, we can check. We can do some checks. We can kind of click on our enemy, right, as an example, and then if we look through, and if I look at AI, look, BP, look what it says here. BP third person character is definitely the target actor. So that's correct. What's wrong? What's missing for my nav mesh agent to move? What else? Come on, guys. We did this all last semester. What's missing from my nav mesh agent? Let's take a look. Here's my enemy. My enemy got the target actor right now. And it says event begin play. This is this. Is this the right event to put it on? The event begin play. What's the better event to put it on? Because event begin play does what? It triggers one time, right? And here's the question for you. Does the target actor, is the target actor in the universe, in the world, when the event begin play triggers? No, right? It triggers afterwards. Yes?
Would we use event actor begin overlap?
You could do that. So you could say that, but I'm saying this is the event. You can do it here, right? Because once it overlaps with a character, then that can happen. Let's try that. Let's remove this from here. And let's say, okay, get the target actor first. That's the first thing we want to do. And then, is this good enough? Because once we overlap, right, that happens when it, we don't want to do it on tick. That would be a bad thing, okay? That would be a bad thing. All right, let's try this. Let's see if this is good enough. And play. Hey, look at that. Okay, optimizations. Here's what I want you to do. I want you to use it so that the only time, let's position our little character here so it doesn't run at all, our little enemy, unless the player triggers, unless the player gets the trigger collider. So there it is. So he's up here now. This is where the enemy is. He's kind of looking in the near middle distance or whatever. Like he's looking way over here. He doesn't see us yet. Maybe we'll even rotate him so it makes it really apparent that he's not looking at us. So we'll say, let's just rotate him. Here we go. We'll rotate him like, you know, something like over this. So he's not looking at us and we're sneaking up on him. And what I want this to do is this. Can you make it so that when we climb the ramp, it activates this dude? Okay, that's the challenge that I want you to put together. Climb the ramp, activates the dude. How do you do it? Otherwise, if he's not activated, he won't be, even if he overlaps, it doesn't matter unless the trigger is set. How do I do that? Yeah.
You start with the detection and the trigger collider because it already detects when the player.
Okay. All right. I like it, but here's the trigger collider. Here's the trigger. Trigger collider doesn't do anything for us yet. It needs to do something for us, right?
Yeah.
So how do we say that the player has been detected, and how do we inform the enemy that the player has been detected in the trigger collider? How do we do that? We got to let the player know. We got to let the enemy know, right? And it's not just one enemy; it's all enemies. What if there's multiple enemies that are going to pass through? We want all enemies to know that the player's triggered an alarm, right? So what do we do? So when the actor overlaps, we can use something like, if I want to try and type, if I type in get all actors of class, right? And again, if I look at all actors of class, if I do BP underscore third person character, then that's all actors of this class. I'm not casting, I'm just, basically I'm searching. I'm searching for all actors. It gives me an array. And then what I want to do is, you know, if any of the actors are, I don't want this. I want all actors of BP underscore enemy. That's what I want. So give me all the enemies. Now you could always save this as a variable. So I can say all enemies, the enemy. But this is the all actors. What I want to do here is I want to do a for each loop. For each, right? And then in the for each loop, what I want is for every enemy to be alerted. Right? So I need to change something for this enemy. Now they are of type enemy, which means what I can say is in the enemy class, I can create another variable. Let's make another variable. And we're going to say something like alerted. And this alerted variable will be a Boolean, right? Let's make it so that it is exposed. We'll make the eye icon come on. And we'll also make it so that it is part of the AI category. Here we are, AI category. So the alerted by default, if I compile and save, is false. It's not alerted. So now what we're going to do is we're going to put a block in here. We're going to say that there is no target actor unless I'm alerted. So we're going to say if alerted. So that means like if I pull in alerted, like this, get alerted, I can do a branch. Right, here it is. And I'm going to say that the only time I care about overlaps with anything is if I'm alerted, if that's true. If I'm not true, if it's not true, I ignore this whole thing. I just turn all these nodes off. Does that make sense? Here's the other actor. I don't even want to cast for the other actor. I don't want to do that. I don't even want to save the other actor as a variable yet. Okay, I don't want to do that. All I care about is, am I alerted or not? Okay, now that I have this, compile and save, if I go back to my trigger, then I can say, okay, well, I've got all the enemies. I want to alert everybody if I go up on that ramp. So how do I do that? I say for each enemy, I want to say that set alerted, right? I want to set alerted to true. Is this enough? Is this enough? This is not enough. Why is this not enough? When does my overlap happen? Is my overlap going to continue to happen? Or is my overlap happening already? So my overlap already is happening. It's already happening, right? So I could make my overlap smaller. I could try and do that. But the problem is my overlap is already taken place, right? Which means, remember we had three things in Unity. We had, an enter, a stay, and a leave. Those are the three things we have in Unity. Do we have something like that here in Unreal Engine? Let's take a look. So if I type in box, and if I go back down to these events, I have on component begin, on component end, and do I have on component stay? I don't have that, right? I don't have that. I don't have on component anything like that. I have on component hit. It says event called when a component hits or is hit by something solid. That's not it. So it's not one of these two, right? So what else could I do? I could search for this every frame, right? Where I could call a function to do this. I can say like, hey, you know what? Check the overlap now. Call event actor begin overlap if this is the truth, the case, or whatever. But that's a problem, right? Because the box, as an example, is just going to trigger it the first time. But that's going to happen every single time, right? But in my enemy's case, this thing here, this sensing radius, it happens one time. It's the same problem that we had before. Look, here are the options. The hit, begin, end, wake, sleep, all these other ones, right? We need something else to activate this. So this is a nice idea if our player was moving closer. Yeah?
Are you meaning like as a way to make sure that this is constantly running, constantly checking?
If we do, that's going to be on like a trigger, like some kind of, a tick event, right? So that's something we could do. But here's something else. In the tick event, here if I talk event tick, could I call something like on component, begin? I can't do that. I can't call, on component begin overlap. That doesn't allow me to do that, right? I can't do that, right? It'd be nice if I can make it so that there is a custom event. I can do that. So what if I had a custom event? Let's try this out. Add custom event. And let's say this custom event is something like a move to. We'll call it move to. All right? And now what I want is I want to separate these two guys out, right? Where the custom event, right, is something that I want to be able to call with my AI. This part, this AI move to stuff. All right? So this stuff, I want to separate it from my overlap. I want to put it here, right? And that's okay. Because a custom event, my friends, is not a function. So this is okay to do. Now it has to be here in the event graph. So now I can call a custom event from here. I can say, move to. That's okay, right? Move to is the custom event that I'm calling. Notice? Okay, this is good. So now this, I don't have to put here, right? I don't have to put that here. I can say simply that, the only time that what we can acquire the character here, as an example, but I only want to move to one time when, right, this is changed. When this is changed. So I can do that too, right? But move to will allow me to do that, right? Move to will say, hey, move to the character, right? This already acquires this, which means, do I really need the alerted branch at all if I'm going to do something that looks like this? All I care is for the component begin overlap to set the target character, and then once I've done that, I just want to call the move to event of the enemy. Of the enemy. Okay, let's try this again. Let's try recoding this, going back to the trigger and saying instead of alerted, what if we just said move to? Right? For each character, for each enemy, move to the character. That's what this is doing. Move to the target. How's that look? Is that going to work better? No tick function, which is good, right? Only when my actor begins overlap am I going to move, right? I'm going to instantly acquire the target actor because I'm already overlapping. so I don't have to cast, right? I'm just going to move this closer, like this, and this time. So this is pretty good, which means I don't need alerted. I can get rid of that. All right, let's try this out. Compile and save. So now, what we want is the only time this is going to move to is if I'm alerted. So let's run this. So it's not moving, not moving. And if I move through here, right? No tick event, no casting, and no extra variables, right? Just using a custom event. Let's try that again. So here's what I did. Now, here's something. What about if I leave the area? If I leave there, do I want him to stop? So I can do the same thing. So if I want him to stop, I want to set the target to nothing. So here's, he left, the character left. I can do the same thing for each this. I can just copy these two things here, right? And again, I can make this into a little function, no problem, right? And for each of them, what I want to do is I want to say that the target, so set target actor to nothing. If I set the target actor to nothing, can the AI move to? No, right? So let's try this out. So as soon as I leave that area, as long as I've left the ramp without him following me, he will stop. Let's try this out. So I'm here, and I go in, and then I leave, and I go in. Oh, what happened? I didn't acquire the actor again, right? I didn't acquire the actor again when I did this. Let's acquire the actor. So how do I do that? Let's do this. So it's on the trigger again, right? So the trigger right now, it says the target actor is nothing. So what if we made the target actor here something? So copy paste. Here's where our refactoring comes into play. All right, so I'm going to say here, I'm going to say target actor, you know, as an example, is set. And I definitely want to do this. My array element, move to. I want to use that part with a reroute node because it's going to still do this. But I want to set the target actor to something. Well, there's other actor over here. Can I do that? Let's do that. So I said reroute node, right? So let's try that. So I want to make a reroute node here. And why can I do this? Because the overlap event only works with players. Right? No casting. So this is where I get the character, and I want to use this one to go here. That's got to go there too, right? So this is where I set the character. This is where I unset the character. Let's see if that works. And if this works, my friends, do I really need the overlap? The sensing radius? Let's try it. I'm in. He's chasing me. I'm out. Oh, man. I'm in. He's chasing me. And then I'm out. Doesn't quite work exactly perfect, but let me see. If I do this, I go, okay, I'm going to move over here, and I'm over here. I've kind of moved in and out. Oh, he's going to chase me. But then when I move out, he stops chasing me. And he stops chasing me right away. Like as soon as I move past this part. He moves, and I've left, and that's it. So we can make it so the trigger is a little bit better than this. This is pretty small. So let's make this so I want it to do what it's going to do. So I'm going to kind of grab this object in the game, which is, let's turn off the AI for now because it's confusing. We want to just grab that object, which is the trigger. Here it is. And I want to make it bigger. I want to make it so it encompasses this whole little block here. All right, let's try this out. So again, I'm just going to change the size. And we'll make it like this. And we'll move it around. So as long as I'm going to make it so that it is in here. Let's say, maybe a little bit bigger. And I'm just going to make this a little bit bigger this way and move it over. Something like that. And I'll make it a little bit taller as well. That makes it so if I jump on there, it's going to work, and I'll make it a little bit wider. Let's do that again. Maybe even wider. Looks like a 12 by 12, maybe, or something like that. What do you think? So now, here's how it's going to work. If I pass through the trigger, right, at all, pass through, he comes at me. And if I leave, right, he should stop. He stopped when he got to me, right? But if I enter it, if I enter this thing, he should come at me, right? So if I enter it, he should come at me. If I leave, he should stop. And let's try that again. So he comes at me, right? And if I leave, he should stop. But if I come closer, he should come at me at this point. There he is. He's going to keep chasing me, right, until he gets me, because his acceptance radius makes him stop, makes him get to me, right? Come at me. If I leave, he's so fast that he's, that's why he's coming at me so quickly, right? So here he is. He's going to chase me. When he got to me, he stopped, right? Because that's what I made him do. There we go. And you can see that you can create almost like little conditions where when you're in there, he's with you, but the leave doesn't seem to work very good. I don't like the leave. So let's take away now, let's take away something. To make it even better, because we don't need, I don't believe we even need this component begin overlap for the radius anymore. Let's get rid of the sensing radius. Let's see if it's enough now, right? So no more sensing radius. Let's get rid of it. Goodbye sensing radius. Actually, let's just do this first. This is gone, and then this is gone. Let's see if that's good enough now. So no more sensing radius. Okay, and the only way he's going to get there if there's a target actor. If there's none, he's not going to chase us anymore. Let's try this out. So this is the refactoring. So now he should get to me, and if I leave, right, he's still getting to me. So what is going on? How come I'm not losing my radius? Let's take a look here. Let's go back to the trigger. So again, event actor end overlap, and when I'm leaving, I want the target actor to be nothing, right? So what did I do wrong? So I hover in, and for every actor, when I'm overlapping, I set the actor to me, and then what I want to do is do this. And I want to think that, I think what I got to do is I got to, so if I want that behavior, because move to, this is a very simple move to, right? Move to will keep moving until I reach the target actor. That's what's going to happen. And even if the target actor is gone halfway through, it won't interrupt this process, right? It won't do that. It'll keep moving until that is going to happen, right? So it says stop on overlap. So is there another way to do this? So one thing to do is if I go AI space, so I can do get AI controller, and I can also do a simple, if I do a simple move to, right? A simple move to actor, there's this one as well, all right? So this is a much simpler way. It's definitely using the AI blueprint, right? Helper library to do this. This one here uses the AI controller to move to a specific location. That's what this does, right? And but what we want is for this to be interrupted, right? We want this to be stopped. So almost like we want to call this and then we want to stop it, right? That's what we want to do, right? So, and also what happens is when he gets to us, he stops. So it'd be nice if we had some kind of timer. So if I type on set timer, as an example, and we can do by function name or by event, right? So, there's these things. So if I set timer by event, then we need the event to set the timer on, right? So notice these two events, they can connect, right? So it's going to call the move to function. We can also call this timer from itself, and you can also not even include it here. Let's undo that. And we can actually call it on, we can actually call this when the, when we overlap for the first time. So instead of calling move to, we can call another custom event, right? That will do it for us. All right, so let's try this out. Let's try a different way of doing this altogether. So move to will leave alone. And what if we had another custom event? Let's try this out. So add custom event. There we go. And we'll call this activate AI. And we'll have another custom event, add custom event, where we deactivate AI. There we go. Okay, that's what I want to do. And the move to function, this move to function, right, that I want to use a timer for this. So when activate AI is called, I want to use a timer function. So set timer, we'll do it by function name. And this time we'll use, the function name that we're going to use is move to. That's the function name. And let's loop it. Let's say let's loop it. And what we want, the return value is the handle. So we want to promote this to a variable. We'll call this the timer handle, right? So this timer handle is going to something that we can invalidate the timer, right? So here we're going to invalidate, deactivate AI. We're going to invalidate timer by handle. And the handle we're going to use is this one. Okay? So a few more steps involved. So now instead of calling move to directly, we want to call this one. Now 0, as an example, is if you hover over, it says how long to wait before executing the delegate in seconds. So do we want to wait to execute, or we want to always be executing? A timer is better than a tick function because what it does is we can stop it and start it and stop it, which is more, a little better. Let's give us a little bit of leeway. Let's only activate it after a second. So that way it doesn't activate immediately. It takes a second for the AI to recognize that we're there, okay? And then it loops. It keeps on looping forever, right? So then what we're going to do is once we've done this, right, and we're calling the move to function, it's going to, kind of detect if the player has gotten there or not. And it's going to create the timer, this move to function every second. That's what it's going to do, okay? So every single time it does that, it's going to call the move to function, right? And then we should be able to deactivate it. So let's go back to the player trigger. And instead of calling move to, what we'll do is we'll call activate AI. So we'll say that, sorry, the wrong one. We're going to call this one. Activate AI shows the wrong one. Activate AI. There we go. And this calls the timer into being. And then from here, what we're going to do is we're going to deactivate AI. So we're going to set the thing to nothing, and then we're going to deactivate AI by doing this. Deactivate AI. And let's see if this works any better than with our plan. All right, again, I'm exploring this with you and see what you think. Again, I'm trying to avoid casting and using tick functions. Timer is better. All right, let's try it out. So here, I'm not colliding, and if I go here, oh man, he's there, and he went, and then after I left, he got to me, but it didn't quite stop. It didn't quite deactivate it. Did it work for you? You're not trying it, Andrew? Let's try this again to show you that it didn't quite work. So, and one thing to also note is when we're playing, let's look at the third-person perspective character for a second. And let's take a look at the enemy. Let's look at the enemy, and let's look to see if they have a, if I go AI, let's see if we can acquire the target actor here. So again, I'm here, and then I've acquired the target actor, and I've left. The target actor is gone, but it doesn't matter because even if the target actor has been gone, the moment I called the event, as an example, here's the event that happened. It acquires me, it follows me, and as soon as it gets to me, it's over, right? If I stay here, right, and if I stay within band, it'll keep following me, even if it gets me. Look, that's what that little little timer function does. It keeps moving to get me, to attack me, even if I'm still within this radius. But as soon as I leave, it'll attack me once and then it'll stop. That's not quite what I want. We're getting there, but it's not quite what I want. What should I do differently? Because it's not really doing the invalidation stuff, the step that I wanted, right? So let's try this out. Let's go back to the trigger. So here's the trigger. It definitely invalidates this.
I just want to say have a nice week. I'll see you next week.
Take care, man. All right. Here's the trigger, right? And it does do this, but it doesn't matter because when I've done this function, it already had the target actor, right? So this won't stop. As soon as I trigger this function, it won't stop. It stops on overlap, yeah, but it doesn't stop this, right? So how do I stop this part? Anybody? We never did this, by the way, in class when we did the AI, right? All we did was we chase. But I want, when I'm over, I mean, it's not bad what's happening right now. It goes and attacks us once and it just stops, right? As an example. But it's not exactly what I want. Okay, homework for you guys, right? Because I don't want to keep going with this. Two things I wanted to show you. One was what happens when I create my own custom collision objects. I wanted to give you that. And the next part is, how do I use it so that I don't cast and I activate an area and deactivate that area when I'm done? Because from a performance perspective, you don't want AIs in a faraway area to keep active with their brain. I want to turn that brain off, right? Okay, that's what I want to do. So your challenge is there a way of stopping the AI, right, by doing what it's supposed to do? And the answer is, think about the custom AI controller. Because our custom AI controller can do all that work for us. Okay? We're just not there yet. All right? So homework, check it out, see if you can do it. And next week when we get back together, we'll talk about it. Questions around this? All right. Hopefully it helps, and it'll help you guys with your game. That's what I'm thinking. Okay? Guys, thank you so much. Next week when we get together, again, and I want to leave you with this thought because we have a bit of a timeline. Here's the timeline. Let's get to that. Here's the timeline. Next week, I give you your assignments. I give you your assignments for this class, for multiplayer, and for Game 2004. You need to be in a group, okay? Even if you're a group of one, sign up for a group, okay? So please do that today. Don't wait till next week, because then you won't be able to see the assignments. And you're gonna be like, Tom, did you post the assignments? And I'm like, yes. But you don't have access to them because you're just not in a group. By the way, 100%, I'm going to talk to somebody about this next week. Someone's going to say, I don't know why, but I can't see your assignments. And I'm going to say, did you join a group? Watch me. It's going to happen, right? Even though I'm telling you this and I send you guys notes, it doesn't matter, all right? Yes?
Theoretically, half it turn off the acceptance radius.
I could do that. Yes,
But
I
it's
could.
not proper.
No, it's not a proper thing. In other words, kill the acceptance radius altogether, right? Yeah. Or make it really big.
See you next week, Tom.
Take care, my friend. See you later. All right.